Question 9. Apply the relationship between power, the work done by a force, and the time interval in which the work is done. And the equation is power equals work over time. Now remember that power has a symbol P, and the unit of power is watts, W. Power is the rate at which energy is transferred. It's how many joules of energy is being transferred from one place to another or from one shape to another. For example, a 5-watt power means that 5 joules of energy is being transferred every second from one place to another or from one shape to another. The power is equal to the work done by the force over the time. Now, since the work is equal to the change in energy according to the work-energy theorem, we can write the power equation as follows. If the change in energy was a change in the kinetic energy, then we can write the equation as follows. Remember that the work is equal to Fd cosine theta, so if we substitute power equals work over time, and instead of W put Fd cosine theta, then the equation for power becomes P equals to Fd over T. If the angle between F and D is not 0, if it's something, then don't forget to put the cosine here. If the angle is 0 or not mentioned in the question, you can discard this part here. Only if theta is equal to an actual number like 30 and 40 that you put the cosine next to Fd. Now remember that d over t, this d over t is equal to the speed. Velocity is equal to distance over time. So the equation becomes Fv cosine theta. If theta is 0, which is most of the cases, then the power is equal to F times V. But if not, then you need to multiply cosine the angle between the force and the velocity vectors. The unit of power is watt, where 1 watt of power is equal to 1 joule per second, or 1 Newton meter per second. Remember, because joules Newton meter. And remember that Newton is kilogram meters per second squared, so that becomes another unit, which is kilogram meter squared over second cubed. You need to memorize the equivalent of a watt using this info right here. Mention the question or example problem 3. An electric motor lifts an elevator 9 meters, so this is the distance, in 15 seconds, so this is the time, by exerting a force of 1.2 times 10 to the power of 4 newtons, so this is the force applied by the motor. How much is the power, or what power does the motor produce in kilowatts? So he wants me to find the power in kilowatts. Power equals to Fd over T. Now, why did I choose this equation? It's because we have Fd and T. If we have, for example, F and V, then we use power equals to Fv, and so on. Here you can see that the distance and the force are in the same direction, and there's no angle mentioned in the question, and hence there is no need to put the cosine angle there. And then we multiply 0.20 times 10 to the power of 4 times d, which is 9 meters over t, which is 15. And that gives you 1.20 times 10 to the power of 4 times 9 divided by 15. That gives you 7,200 watts. Now, if I want to find it in kilowatts, I just divide by 1,000. And that will give you a 7.2 kilowatts. Question 17. An electric motor develops 65 kilowatts of power. So this is the power in kilowatts. If I want to turn it into watts, I need to multiply by 1,000. Remember, from watts to kilowatts, or from a unit to kilo unit, we multiply by 1,000. But, if I want to turn from unit to kilo unit, I need to divide by 1000. But if I want to turn from kilo unit to unit, I need to multiply by 1000. So here we need to multiply by 1000 to turn it into watts. As it lifts a loaded elevator 17.5 meters, so this is the distance, in 35 seconds, so this is the time t. How much force does the motor exert? So here we have power d and t, and he wants me to find F. According to the equation, P equals Fd over T, which has all of the knowns and unknowns, we substitute and find the force. Now the power is 65,000 after multiplying by 1000 to turn it into watts. So we have 65,000 watt equal to the force, which is the unknown here, multiplied by the distance, which is 17.5, divided by the time, which is 35. Using the shift solve on the calculator, 65,000 is equal to fraction. We have x multiplied by 17.5 and divided by 35 seconds. Shift calc equal, and it gives you 130,000 Newton. So the force developed by this motor is 130,000 Newton. If you want to turn it into kilonewton, you just need to divide by 1000. Very good. So that gives you 130 kilonewton. A pump was used to raise the amount of water weighing 200 newtons. So this is the force applied. If I want to lift something up, I need to apply a force equal to its weight. So this is the force I need to raise, or the pump needs to raise this weight of water to a height of 5 meters. So this is the distance that we raise the water in during 2 seconds. So this is the time. What is the power of the pump? Well, we're going to use Fd over T again. The force is 200, D is 5, and T, the time is 2 seconds. That will give you 200 times 5 over 2, 500 watts of power. This is the past ministry exam. It says an elevator lifts a total mass. Oh, there's a difference here. They didn't give you the weight, he gave you the mass. So this elevator lifts a mass of 1,500 or 1.5 times 10 to the power of 3 kilogram, a distance of 50 meters in 15 seconds. What is the power does the elevator deliver? So first thing, if I need to lift an object upwards, I need to apply a force on it equals to its weight. Now given is not the weight of the object, given is its mass. So its weight is equal to mg. So multiplying 1.5 times 10 to the power of 3 times 9.8 gives you the force, gives you the weight of the object, in which case is the force applied by the elevator to lift that weight. So the mass 1.5 times 10 to the power of 3 times 9.8 gives you 14,700. Remember, this is the same exact question I got you in the exam. All right, so this is the amount of force I need, or this is the amount of force the elevator is applying to lift the mass. Now that I have the force, I can use the power equation to find the power. The force that the elevator is exerting is 1,000 or 14,700 times the distance is 50 meters divided by the time, which is 15. Using the calculator, we multiply that by 50 and divide by 15, gives you 49,000. 49,000 watts. All right. The other questions, you can see their solution in a minute. Here are the rest of the questions. You can pause the video and try to solve them. They are solved exactly the same way we solved the previous questions. These also Let me exit because some of the questions are not showing. So this is question 1, question 2, and question 3.